When the electrical load on a utility system increases beyond its design capacity, several factors contribute to a decrease in frequency. Firstly, prime movers driving the generators, such as turbines or engines, attempt to maintain a constant speed to generate a constant frequency. However, as the load increases, the prime movers experience an increase in torque resistance. This increased resistance causes a decrease in the speed of the prime movers and, consequently, a decrease in the frequency of the generated electricity. Secondly, generators have internal impedance, including both resistance and reactance, that opposes the flow of current. As the current flow increases due to the increased load, the voltage drop across the generator's impedance also increases. This voltage drop reduces the effective voltage at the terminals of the generator, which then leads to a decrease in frequency. Thirdly, the rotating mass of the generators and prime movers has inertia. When the load increases suddenly, the inertia resists the change in speed. This resistance causes a temporary mismatch between the load and generation, which contributes to a decrease in frequency. Fourthly, the automatic voltage regulator, known as the AVR, is a control system designed to regulate the generator's field current to maintain a constant voltage. As the load increases, the AVR responds by increasing the field current. This increase in field current increases the generator's magnetic field strength. However, this response initially causes an increase in the generator's reactance, further contributing to the voltage drop and frequency decrease. Fifthly, the type of load connected to the system also affects the frequency response. Inductive loads, such as motors, tend to draw more current at higher frequencies, which can exacerbate the frequency decrease. Capacitive loads, such as capacitors, have the opposite effect, slightly mitigating the frequency drop. In summary, the frequency drop during high load conditions is a result of the combined effects of prime mover regulation, generator impedance, system inertia, automatic voltage regulator response, and the specific characteristics of the load connected to the system. The prime movers are designed to maintain constant speed, but increasing load causes torque resistance, slowing them down and reducing frequency. Generator impedance leads to voltage drops that further decrease frequency as current increases. System inertia resists sudden changes in speed, creating a temporary mismatch between load and generation. The AVR attempt to maintain voltage can initially worsen the frequency drop due to increased reactance. Finally, the type of load, whether inductive or capacitive, influences the extent of the frequency decrease. These factors work together to explain why increased electrical load causes utility frequency to decrease. Understanding these mechanisms provides a comprehensive view of power system dynamics under stress.